So, on a previous class, we discussed comparative advantage. We defined how everyone does the best when each person concentrates on the activity for which their specific opportunity cost is the lowest. So we usually have this situation where multiple people are faced with multiple tasks. How do we actually divvy up and assign the work? Through specialization and trade. So we can actually make more things with the same amount of inputs with specialization and trade. So our total output can increase using the same 8-hour workday, which we saw with our example with Zin and Anna having to do with web updates and bike repairs. We're not going to go through this example. Again, if you want to go through it, it is online in our playlist for a video that was on Wednesday. We're going to do another example here in a second anyways, but the gist of that was we get 12 more repairs for the same amount of inputs, right? So we did that little example ourselves to make sure, okay, the math checks out. Indeed, if they were to just split their time half and half and each do, half of the demand of what there is to do, then they would actually be producing fewer goods and services than by specializing in their comparative advantage. So they specialize in their comparative advantage and they get 12 more repairs. So let's go ahead and do another example just to really cement that stuff in. And so this one we're going to talk about, again, web repairs and bike updates, bike repairs, web updates and bike repairs. But this time we're going to use Monique and Miguel. So we'll make another chart here. We'll use Monique and we'll use Miguel. And again, we've got websites, updates, and then we have bicycle repairs. Excellent. So we are told the following information. It takes, in an hour, Monique can do 2 updates. And in an hour, Monique can do 1 bike repair. Miguel, in 1 hour, can do 3 updates. And in that same hour, can do 3 repairs. So, first of all, we can tell instantly who has the absolute advantage in things, right? It's either the person who can produce the most amount of stuff in the least amount of time, or, given the same amount of time, can produce the most amount of stuff. So, in this situation, Miguel, in the same hour, can produce 1 more website update and 2 more bicycle repairs. So Miguel has the absolute advantage. Now, does this mean that we should just have Miguel do everything? No, right? We know that having Miguel specialize in the thing that they have the comparative advantage in, and then having Monique specialize in the thing that they have the comparative advantage in, is going to result in greater output given the same amount of resources. So, to figure that out, we have to figure out the opportunity cost per unit. So we'll make another chart here. We'll call it the op cost table, rather. It's not a chart. We'll keep it the same. And so on your own, good little check, right? Go ahead and figure out what is the opportunity cost when Monique does a web update. How many bicycle repairs is she giving up? So Monique is giving up 1/2 of a repair. And in a similar way, how many web updates is Monique giving up? What's the opportunity cost when she does a bicycle repair? 2 updates. And so with Miguel, it ends up being pretty easy, right? It's a 1-for-1. And so figuring out who has our comparative advantage requires that we kind of look at each one separately, right? We look at this first one and say, okay, who has the lower opportunity cost? Monique does. So Monique has the comparative advantage in web updates. And then we ask the same kind of question in terms of bike repairs. We say, okay, who has the comparative advantage in bike repairs? What's the lower opportunity cost? It's going to be Miguel, right? Miguel's giving up 1 update for every bike repair compared to Monique, who's giving up 2 updates. So we would have Monique specialize in web updates and Miguel specialize in bicycle repairs. Okay. So where does comparative advantage come from? And there's more examples of this online. I'll provide some more links, and we'll have more practice this week in our quizzes. So the first source of comparative advantage is just, natural raw talent, skills. The second one, if we kind of zoom out in terms of not talking about peoples, but we're talking about regions or countries or maybe continents, I don't know, but natural resources, right? If you are a landlocked country, you are oftentimes poorer. You are oftentimes of a lower socioeconomic status because you don't have access to trade. You have to go through these other countries. And so just the natural resource of having a port is a huge thing to being able to specialize in something. People countries that have oil and gas, right, are able to specialize in those technologies and are able to export that, and more output is able to be made with the same amount of human input and resource extraction. Now, what's the toll of that? That's a whole different subdiscipline of economics, right? The other source is cultural or societal norms. What do we mean by this, right? What do we mean by societal norms? So the first one that the book talks about is languages, right? So just the fact that we speak English, that English is the global, language of trade, and is kind of taken over as a global language of diplomacy from French, right? Even though I think technically that's still the UN language, but let's be real, it's everybody's learning English as a second language, and where maybe half of us know Spanish as a second language, but that's for the most part, there's very little value in learning any other language besides Spanish in your day-to-day life in America, right? So just knowing English is a huge advantage that we have, that our country has, because again, the global trade, the global financial structure, programming, things like that, right? It's all in English. And then institutions. So this is one of the ones where it's kind of more amorphous, it's more esoteric, it's more difficult for us to really place a definition in terms of these institutions, right? But it's the protections and the norms that are around businesses and around inventions and things like that, right? So having a value placed on craftsmanship. That's an institutional value. Having support for entrepreneurship. Support for entrepreneurship is built into the American DNA, right? In a lot of European countries, they don't have the ability to file bankruptcy. So if you make a business mistake, you're done for, right? You have to dig yourself out of that hole. Whereas in the United States, you can just say, oh, I don't know, I want to start over, right? And I mean, it's not always that easy. Different types of bankruptcy involve different amounts of how much you have to repay your creditors and so on and so forth, right? But just having that protection built in so that people feel more comfortable to take risks and be entrepreneurs, some say is part of the reason why entrepreneurship thrives in the United States. Okay, so our next model that we're going to be learning, our next economic model, is called the productions, and we cannot see that green, so let's take that out of there. The productions possibilities curve, also known as the production possibility frontier. So you'll also see it abbreviated as a frontier, but our book says curve, so we're going to stick to that when we are taking notes. But just if you're looking at videos and you see something that says production possibility frontier, it's the exact same thing. So what is this doing, right? What's our definition here? Well, this is a model that shows, so it illustrates the combination of two goods or services that can be produced with given resources. So let's go ahead and talk about one. So we're going to have coffee on the y-axis, and this is going to be in pounds per day. And then on the x-axis, we are going to have nuts. And again, this will be in pounds per day. And so we're given some information. We are told that in any given day, we can spend all day foraging and roasting and grinding coffee and get 24 pounds of coffee per day. Or we could spend all that time foraging for nuts, cracking them open, whatever the case may be, and we will end up with 12 pounds of nuts. And then we're given some combinations in the middle. So let's say we just want 8 pounds of nuts, and we want to take the rest of the day to go look for coffee. Well, given that straight trade-off, that would mean that we would then be able to forage and produce 8 pounds of coffee. A similar note, if we did 4 pounds of nuts a day, we would be able to get 16 pounds of coffee. And so we go ahead and we connect the dots to make a mostly straight line. And then we use the law of large dots to make all those dots fit on that line. And this thing, that's our production possibility frontier, production possibility curve. So it's telling us all of the attainable combinations of resources. So this point here, this point A, this point B, this point C, and this point D, they are all obtainable. When we go outside of the curve and try to do something like 8 pounds of nuts and 24 pounds of coffee, we end up with this point E, which is unobtainium. No, unobtainable. Did you guys ever even watch that movie Avatar, the first Avatar? It was like so long ago. They're making a second one. They've spent like millions of dollars, and they're doing it like in 3D still, even though that's like such an antiquated technology. Like James Cameron's just like, nope, I got the budget, I'm doing it. So unobtainable, not unobtainium. Unobtainable, right? Can't have it. We just can't have it. Given the existing constraints, existing technology, so on and so forth, we can't have point E. There's one more type of point that we need to talk about here, and that's going to be inside of the curve, right? So what if we spent the day gathering 4 pounds of nuts and 8 pounds of coffee? So this is a point that it is obtainable, right? Because essentially everything that's in this triangle is obtainable. But this is what we call inefficient. This is an inefficient point here. We are not utilizing all of our resources to the best of our abilities, right? So, just we've decided to be inefficient. We've decided to take the rest of the day off and only gather 4 pounds of nuts and 8 pounds of coffee. So it's totally obtainable, but it's not the most we could be doing given that, again, like 8-hour, expected workday. And so throughout this whole thing, right, when we're going from point A to point B to point C to point D, right, we are illustrating the scarcity principle, right? Whereby we have to give up one good to get another. Questions on production possibility curve? Okay, cool. So let's go ahead and talk about gains from specialization and trade. So without trade, you can only consume along your possibility curve. But when you have trade, you can then consume more than you create, so more than your production or your output. And we illustrated this with that example on Wednesday. That with trade, you can end up with the same amount of resources getting more output. So by producing according to comparative advantage in trading, you can get what you want. And so the book does a nice little, walkthrough of this in chart form, but really at the end of the day, the important bit to keep in mind is if this is Tom's production possibility curve, and if this is somebody else on the island, let's say Krisha, with trade, they can get a point that's out here. So this point where it's 12 pounds of coffee and 12 nuts per day. This is achievable only with specialization and trade. So this is our individual, person or company or whatever family production possibility curve kind of analysis, right? What if we zoom out? What if we zoom out and take a look at the production possibility curve for an economy? And so again, we're still going to have the same y-intercept. Not y-intercept, but y-axis. So we're going to be using coffee. But this time, because we're talking about an economy, we're going to talk about thousands of pounds per day. And then on the x-axis, we will have nuts. And again, this is going to be in thousands of pounds per day. It's always good to keep the units of the axes the same if you can, right? You can't always, but if you can, it's a good idea. So when we zoom out and we take a look at an economy writ large, we end up having something that looks a little different. We end up having something that is bowed outwards. So we end up having this outwardly bowed curve, where we still have the situation where the intercepts, right? This is still telling me the maximum production of one good. This is saying if we decided entirely to focus on coffee, we could get 100,000 pounds per day. And likewise, over here, this is saying if we just focus on nuts, we would end up with 80,000 pounds per day. But what ends up happening is that because of the fact that when we talk about an economy, we end up having a lot of different people with different skills. So some people may be better suited to gathering nuts and cracking the nuts open. Some people may be better suited to gathering the coffee beans and roasting the coffee and grinding the coffee, or whatever the case may be, right? Making the actual coffee drinks. So again, that's that video at the beginning, right? It's the guy's like, I don't mow my own lawn or fix my own faucets, right? I pay somebody to do that, and I specialize in economics lectures and economics videos. So we have different opportunity costs for all these different people. There are some resources that are better suited to coffee, and there's also just gonna be like some land that's better suited to, for one crop or another, better suited for grazing rather than growing crops, right? Some resources that are better for coffee, and some that are better at nuts. So we end up with this bowed out shape because when we start to try to force too many of those resources that are better suited for something else into any type of nth degree, right? So if we are already at the point where we are producing 90 and 30 pounds of nuts per day, if we wanted to go ahead and produce 95,000 pounds of coffee, we would have to give up 10,000. So this is going to be a change of 10 in order to get an increase of 5. So we are giving up more the more we get to those intercepts. So again, the more we're trying to jam that circle, block shape into the square hole, the more expensive it becomes in terms of the other resources that we are giving up, the other output that we are giving up. So the principle of increasing opportunity cost says that we are going to start with the resources with the lowest opportunity cost. Whoop. Too much zooming out. Zoom in again. And then you're going to move to the next highest opportunity cost. And still higher. And throughout this, right, there's decreasing productivity or declining. It's got to be difficult to read Japanese. I'm down, you know. So we will have some shifts in the production possibility curve that tell us different things that are happening. So the first shift that we'll talk about is a shift that is a neutral technological or technical improvement. So a neutral improvement is going to increase both the production of coffee and nuts, both exactly the same. If we ended up just having a technical improvement in coffee production, we would end up with our original production possibility curve expanding out, but only around coffee. So it would pivot from the hinge, so to speak, on the nuts axis. And of course, for completeness, right, we got to talk about a technical improvement in nuts. Something like that. Maybe my pen and colors will catch up. There we go. So pivoting around the coffee axis. So any questions on the production possibility curve or the shifts therein? So we'll have more practice on that as well this week in our quizzes. All right, awesome. Let's go ahead and jump into Chapter 3, Supply and Demand.